Suppose you were taking a 2-week holiday on a giant cruise ship on the Caribbean. Now, cruise ships generally weigh the equivalent of 30,000 adult elephants. So how does something so massive and heavy float? Ships have to withstand the tremendous burden or weight of the ship, along with the crew, luggage, supplies, and passengers. In other words, they float. Floating means remaining suspended in a fluid. They do that with some help from the principles of density and buoyancy. But first, what is buoyancy? Buoyancy is the tendency to rise and float in a fluid. Imagine you have a cruise liner submerged in water and gravity is acting on the ship because it has mass. The pressure of the fluid will also be acting a force on the liner, except the opposite direction. It will display an upwards force on the ship. This is called the buoyant force. Now, if the liner's density is less than the amount of fluid displaced, then it should be able to float on the surface of the water. For example, an ocean liner is less dense than a marble, so it floats in water, but the marble would not. Factors that help an object float are enclosed volume of air, like in a cruise ship. All the compartments and rooms are basically pockets of air. Secondly, the weight of the ship is spread over a large surface area, much larger than a marble. If you were to take a marble as heavy as an ocean liner, well, you wouldn't be able to take that then, and place that marble and the liner on the water at the same time, then the marble would sink, even though they have the same weight. The ship would be spread over a larger area, and the force can act upon the bottom of the ship. The marble is smaller, much more compact, thus it would sink. This leads us to Archimedes' principle. Archimedes was a man that lived around 210 BC in ancient Greece, Syracuse, Sicily. According to Vitruvius, a crown had been made for King Hiero II, who had supplied pure gold to be used, and Archimedes was asked to determine whether some silver had been used instead by the dishonest goldsmith making the crown. Archimedes had to solve the problem without damaging the crown, so he could not melt it down into a regularly shaped body in order to calculate its density. How did he do it? According to modern myths, he was taking a bath, and during that bath, he noticed that the level of the water in the tub rose as he got in, and realized that this effect could be used to determine the volume of the crown. For practical purposes, water is incompressible, so the submerged crown would displace an amount of water equal to its own volume. By dividing the mass of the crown by the volume of water displaced, the density of the crown could be obtained. This density would be lower than that of gold if cheaper and less dense metals had been added. The test was conducted successfully, proving that silver had indeed been mixed in. This principle is very famous now, around 2,250 years later. Archimedes' principle can be summed up pretty short. The buoyant force acting on an object equals the weight, which is the force of gravity, of the fluid displaced by the object. Yes, liners displace water as well. They displace the equivalent amount of water when they press down on the ocean, which meanwhile pushes up and keeps the ship afloat, or buoyant. Engineers help ships to achieve buoyancy by choosing lightweight, sturdy materials and dispersing the weight of the ship across the hull. The hull, or body of the ship below the main deck, is typically very wide and has a deep baseline, or bottom. Large ships, such as freighters, naval vessels, and transport and cruise ships, commonly use displacement hulls, which are hulls that push water out of the way to stay afloat. There are two main types of hulls, V-hulls and U-hulls. V-hulls are fast, aerodynamic, and cut through waves efficiently. U-hulls are slower, but rise out of the water more, making the ship extremely stable and seaworthy. Cruise ships usually have U-hulls. They minimize seasickness and allow for a smooth ride even in big waves. The Titanic is an excellent example of the misuse of a V-hull. The Titanic should have had a U-hull, when in fact there was a V-hull, therefore it was fast. It had a bit less surface area than a U-hull would have, and when the Titanic struck the iceberg that it did, it might have survived because there would be more buoyant force acting on it. There were multiple reasons that led to the Titanic sinking, but a U-hull would have helped a bit, at least have the effect of making the Titanic sink for a longer period of time, not the record-breaking 3.5 hours that it actually took. I hope you found this educating and entertaining, and happy sailing. Thank you for watching.